Hello and welcome back to the lab. Today on the bench we have a Tektronix 7904 oscilloscope to go with the 7904As, or the one 7904A that I have here in the lab. Quite a bit different between the 7904 and the 7904A. We will get into some of those differences later in the video. Also, quite a bit different between the individual 7904s depending on their serial number, and we'll get into that as well. The older units, they did hit 500 megahertz, but there was a lot of there were some incredible design efforts to get them there, and not all of the timing worked. They weren't as interchangeable as the 7904A. The 7904A, the A variant, is much more easily, plugins are much more easily moved around, especially if you want to go fast. This is primarily talking about the three fastest sweep speeds. I do have three 7904s, all in different states of repair. The gentleman that I picked these up from said two of them were working. One of them was pretty rough. So we're going to go through them together, see what's salvageable in that and what's not salvageable in that. I did see inside one of the one that's the roughest, and it has some issues that might be terminal with the frame, but we'll see where we go from there. There's some plastic parts in there that are cracked off, and that's going to be a big problem. In this one, this is the highest serial number that was in the bunch. I was told the previous owner switched it out to a blue tube, so we have a I think that's a P11 phosphor in that one, and it was working. So we'll go ahead and give it a shot and see what happens. Okay, we have a power supply in tick mode. I can hear it. It's very soft. You guys can't hear it, so we're going to shut this off. One of the things I do know about these scopes is the 7904 and the 7834 both have the exact same power supply in them. Those power supplies actually suffer from an ESR problem in the tantalum capacitors in there. So before we go too much more forward, I'm going to pull out the power supply and we're going to swap all of the tantalums on the low voltage board. I'm not usually a fan of shotgunning components. However, this was one of the first switching power supplies that Tech did, and it is very sensitive to the ESR in the tantalum. So if that gets too far out of spec, power supply goes into tick mode and won't start. So let's get those replaced, and then we'll see what happens with the scope. That should maybe bring it back to life, and we'll see if we have any other problems. You can also tell this is one of the newer ones because this is an NEC power connector on them. Tech did that before. The other two scopes have a fixed power cable, so they are much older. I've checked the serial numbers of the other two units while we're doing this in real time, just pulling this power supply apart. One is very early production. The other one is middle production. This one is late production. So we actually have examples of all three of the units. So the 4 screws, this will then pop backwards, being careful of the plugs because they are tight. And I'm going to take some pictures of the top sides of these, of the top side of this board. So when we go to put everything back together, the rails go in the right place. Okay, bird's eye view into the top side of the unit. These 3 connectors have to come off here, here, and here. This exposes the low voltage regulator, which is where all the problems are in these units typically. Here's one of the tantalum capacitors. There's a couple more scattered throughout, and we'll get to it. One thing to note with it that's different with the 7904 and the 7904A, the high voltage supply for the CRT is in the power supply unit underneath. So that is something we will have to deal with as well. Okay, we need to get to the board that's back here in the power supply, so we're going to have to pull it all the way out of the scope, which means we have to disconnect the high voltage lead, we have to disconnect the high voltage power supply, a few other things. This warning right here, 21,000 volts CRT anode voltage discharge CRT lead to chassis when disconnecting. I did discharge this lead to the chassis, drew a significant spark into the chassis, but it's discharged now. Everything is safe and everything is good. But even though the scope didn't start, there was still voltage on the tube, on the anode side of the tube, which needed to be grounded out to the chassis. Heed the warnings. That would have been a zap. These are the other lines that need to come out. I want to get a picture of the orientation of that plug so I don't, when I hook all this stuff back up, we don't release the magic smoke. One other thing since we're in here to note, these blue connectors, these crumble in some of these units very, very badly. This one's doing okay right now. There's something in the blue harmonica connector, this light blue one. The dark blue one seemed to be okay, and all the other colors seem to be fine. They seem to be holding up. But there was a dark blue harmonica connector, and it just crumbled in my hand on a few of these units. So you might need to get a different color or something like that. Obviously, in this case, it's something chemical in the dark blue one. Okay, quite a bit of stuff needs to come out to get this power supply out of here. So the ground connection needs to be undone here. Also, the power switch from the front of the case needs to come out. So that was a trick to get out of there. Dropping this in the case, which is the anti-rotation ring focus, there we go, for the power supply, or for the power switch, was kind of a pain in the butt, and that's hard to reach, so that's not going to be fun to put back together, but we'll get it done, no problem. So for right now, let's get the cover off of the power supply, see what we're up against. More warnings, because we're taking the frame off the power supply. 3 kV under it, and rectified line voltages. So there is definitely some spicy stuff under here. Now there should be a neon in here, if I can find it, to notify you that the bulk caps are charged, but I don't see it. However, we are going to let this bleed off. This is the main, well, like here's a bridge rectifier and diodes and a few other things. This is one of the main boards of the power supply. Actually, this is a very similar topology to the 485 that I worked on before. Lots of tantalums here, here, over here, these two. And a couple of electrolytics that could go sideways, these guys. The inductors look okay. Nothing looks burnt, which is good. A custom tech I see here, probably just a guess, I'd have to look it up, but an early switching controller. The bulk switching capacitors are down low, which are going to be, they're going to have a huge charge on them. Let's check it with a meter before we really start poking around in here. I am not looking to get zapped today. I am still going to check these with a DMM, but our safety neon is right here. Okay, let's check these screw terminals with a DMM. We are at 400 millivolts and 200 millivolts, so we're good and discharged. So this is safe to handle. Those bulk filter caps are directly rectified mains, so the mains comes in, is rectified here, and then it feeds those bulk filters, and then that's what drives the switcher. So there is a substantial amount of voltage on there, and even more so if you're in the 230, 240 volt regions of the world. I'm in the 120. But we'll get to work on the top side, replacing capacitors. Okay, after a fair bit of solder work and getting everything repaired, we have all the tantalum caps replaced in the power supply. I haven't done the electrolytics yet, but I want to see if this will bring the supply back to life. So I'm going to button everything up, toss it in the scope, and we'll see what happens. It's always a catch-22 how far you want to take a rebuild like this. We could replace every capacitor in here. We could replace none of the capacitors in here. Obviously, this supply had a problem, so it did need some repair. I did find some of the tantalums that did go leaky. They weren't completely dead shorted, but they were running about 7K of resistance, so they were not capacitors anymore. So we may have other problems with this power supply. I don't quite know yet, but it is at a place where we can step test it. So I'm going to put the lid back on because there is some wildly spicy stuff going on in here in terms of voltages, and we'll get it all back together. The capacitors that were put in were well overvolted for their rail. I have 100 volt caps on 20 volt rails. They're not going to have a problem ever again. So nice and set up. If the hive mind of the internet, of which I guess I'm a part of, given that I have a YouTube channel, is accurate, my scope should fire up. But we'll see. We will resistance test the rails before we turn the scope on, just to make sure there's no other shorts, and hopefully we see some traces. Okay, I have the scope hooked up to the isolation supply. None of the power rails are shorted. Everything seemed to be okay. I have all 6 bulbs switched in. We're going to switch the power switch on. I have not hooked the power switch back up yet, because that's the biggest pain in the butt part for getting this thing to go. So we are now in the on position. I'm going to turn this on. If any excitement happens, we will catch it on camera, because we are in real time, and, well, I'm in real time, and this is YouTube, so here we go. Nope, switcher's still not happy. It's not blown up, but it's not happy. Okay, well, we're not in tick mode anymore, and the switcher's trying to start. It's just not running correctly. So we're going to look at that switching board again, so I have to disconnect the scope again, or pull the power supply out again, and go from there. But I made it easy to pull the power supply out. But I wanted to get this on camera. Every time this lead gets disconnected, it was bled off. At that point, heard a small snap, but nothing like it was before. So we are trying to get high voltage. It's trying to start, but we still have some more troubleshooting to do. Pop this cage out, and then we're going to take a look at the switching board. Okay, so continuing with the saga of this 7904, I've taken one of the power supplies from the other units, put it in. The power supplies are interchangeable in the model line. So I heard the tick, and it stopped ticking, so it's coming up. Now, given the way I have the front panel set, this is giving me some cause to concern, because I don't have graticule lights, and I don't have intensity yet. But if I wait a minute, I should get those, theoretically. There come the graticule lights. And one of my other rails just came in. Lights, and there's the trace. So the frame is working, but that startup sequence was far too long. It should not have taken that long to come up. So this other power supply is also having issues. So we're into repairing power supplies. Now, these power supplies are a pain in the butt. They really are. They're switching supplies. They will not start if they don't have a load, so you can't fire them up on a bench. All kinds of problems with them. I've recapped it, done a couple of other recaps, and it's squealing like we heard. Get some more capacitors I have to put on it. I have asked some questions of the hive mind, and the general consensus is also to check the diodes for leakage, because some of the diodes in the low serial number power supplies can go leaky. This is a mid-serial number power supply that's in there now. We have a high serial number power supply that's broken, and I have a low serial number scope that's ticking, but probably has some faults on the power rails. So I've got a mess, but what we're looking at doing is getting it all cleaned up, which we will. Obviously, this particular CRT has the P11 trace. I do not like the neutral density filter on here. I would prefer a blue one, which I have, so I'll swap that out. The neutral density cuts the brightness of the tube significantly, so yeah, see, one of the rails is having some trouble. You have to drive the tube harder to get a readable signal through the ND filter. So it's better on tube life to have either the clear or the blue, or actually the best contrast would be a green, but Tech never made one, so I am looking at options to make a green filter for these, but that's where we're at. So let me pull this scope off the bench, get the power supply back up on the bench, and tear into it some more. All right, well, I don't say this very often, but temporarily, this thing's actually probably going to beat me. I've been over this power supply for the last 3 weeks real time. It's been kind of crazy. I've had 2 cap orders on this. I'm going to need a third. But this thing's just not starting. It's back to being in tick mode. If I leave it in tick mode for too long, it is blowing the fuse. The waveforms are kind of looking right, but not quite. And we still have some issues that we're going to need to sort out on this particular power supply. So I can take the working power supply, we can throw it into this scope, and we can get the scope working temporarily. But then I have a power supply that needs help, because that one's not 100% right either. It's having issues starting in the lamps and things. This is actually one of the other 7904 frames. That's why it looks a little different. This is the mid serial number frame with the high serial number power supply, and it's still in tick mode. So the only way I can progress from here is I'm going to need to get a load to fire up the power supplies and actually get them fixed. The problem is I can't just use my single load that I have in the lab, because I'm going to need to load 3 or 4 power rails to get the thing to wake up. So, and I need significant draw on those loads, about 36 watts out of the power supply on, I believe, 4 power rails. So there will be more troubleshooting on this. We will hit this again. I'm not giving up, and I don't take some of this lightly. What I'm going to do is I'm going to put the other power supply in this scope, see if this frame fires up like it should. But yeah, so we'll get some load resistors. I may even add a couple of electronic loads here in the lab, just do it with loads as opposed to resistors. But we're fighting a multi-rail power supply. Multi-rail power supplies are always fun. I've even checked, I've gone so far as I've acquired, the lab had a spare Tech switching IC. Check the switching IC with the working power supply. It's still having some trouble. We are back on some of the tantalum capacitors because some of that, I'll be perfectly honest, some of the capacitor values that I picked for some of the caps were quite poor and not appropriate for the positions they were in, and that was causing me some of the problems. But we've got that all sorted, but we still have a non-functioning power supply. So, and from everything I've seen online, these power supplies in particular the 7904s, they are kind of frustrating and difficult to work on. As these 7904 frames are my frames, I don't have a customer waiting on those. These can take some time. I have some customer units that I have to get on the bench and get through. So these can go to the back burner for a little while I get some appropriate things hashed out and fixed on this power unit. But in the short term, let me get the other power supply put back together. We'll swap it out one more time, see if this scope fires up. If this scope fires up, we'll start, I guess I'll start my restorations with this one. The other 7904 frame, just from doing some troubleshooting, it had a blown out tantalum capacitor, but it had a blown out tantalum capacitor in one of the worst spots in the scope to get to. It is a royal pain in the butt. It's on the main board on this side, back here, and underneath the vertical amplifier. So that's an absolute nightmare to get to. I need to figure out what part to put in that position and go from there. But so we'll do a deep dive into one of these switching power supplies and see if we can't get it fixed and go from there. There was a lot of revisions between the serial numbers. There was, I think it's 4 part changes as things progress down the line. So more is always on the way, and we will get some stuff going. But let me get this swapped out, and we'll see if this guy fires up. So this board that we're looking at right now, this is the semi-regulated board of the power supply. This is the switching section, switcher board. So we have the inverter board, we have the semi-regulated board, we have the regulator board and assembly on this power supply unit. So this is all in one cube. Some of the cautions here are we do have the high voltage supply. This is the 21 kilovolt lead. I am going to snap a nice picture on this due to the caps are actually labeled with their capacitor number. I didn't realize, when I first opened this up, I didn't notice what all this writing was. Well, I noticed the writing, but I had no idea what it was. And from being in the schematic and data sheets for so long, these are the actual cap numbers, diode numbers, and component numbers on the board. Don't know why this is done this way over time, but somebody felt the need to do that. This one may have had some servicing and troubleshooting work. This is the switching controller right here. And these 4 caps, this is one of the places where I made some mistakes in my component choice. These 4 caps are part of the switching controller power supply and startup circuit, and their values are actually very critical to get the timings right. So you have the 2 supply capacitors, the 7 volt, and actually I think it's these 2. No, it's these 2 are the supply capacitors, the negative 2 volts and the positive 7 volts. And then these 2 are the phase detector caps, and this cap has to be bigger in value than this cap. You have a 2 microfarad cap, and then you have a 2.7 for the phase detector. So, and the way this thing starts up and is powered is very weird. It actually draws power from this transformer. If there's no current through the current sense transformer, it doesn't power up the switching regulator, which can't fire the switching transistors and actually get the thing to go. These 2 caps are also of a critical value. This one right here and this one right here. Those 2 caps are in the base drive of the main switching transformers, which are here. It's a good thing to note all of the warnings that are in here. These caps are at rectified mains voltages. These are the switching transformers. They have the voltages on these caps across these transformers. This is a very dangerous supply to work on. To really troubleshoot this supply, my lab's not quite equipped the way I want it to be. Probably going to need to pick up a differential set of probes for the scope so I can really see what's going on. So this one's gotten pretty far into the weeds, and it's not for lack of trying. I had all the caps off, put regular caps on. ESR wasn't good enough. Had to pull them all back off, reverted a lot back, and as I reverted things back, the waveforms changed a little bit. I was taking my waveform measurements off of this point in the circuit here, which is the main switching transformer drive leg, and working on it from there. So that is what happened. Lots of troubleshooting, didn't really go anywhere, but lots of knowledge learned on how this supply works and functions. Still quite a pain in the butt. However, once I get a load, because I really can't troubleshoot anything with the frame, with this unit, you can see how compact, or how much is actually in here. with the cube in the unit, the only thing that's exposed is a low voltage power supply. I can't get into anything to probe anything or anything like that. So I'm going to need to make an external load to get this fired up on the bench so I can actually work on the supply. We're going to do that. We're going to get into a lot of the safety precautions on doing that safely, because I don't want to take 300 volts out of those caps at all. That would just not be a good day. So I'm going to get the shield on it. This is hidden by this shield. So when everything's all put together, all this stuff gets tucked nicely inside like so. And then we'll get this thrown back in the scope and see if this scope fires up. All right, so the working power supply in its home frame is in tick mode, which means this frame's probably going to have a issue. This frame probably has a short in the power rail somewhere. So of the 3 7904s that I have in the lab, all 3 of them are busted for different reasons. So that's entertaining. Oh, this was just a troubleshooting step. I didn't realize it. I had the switch in the on position when I plugged in. It just started ticking. So typically I have the camera on for these things, but this particular unit had other plans. Definitely going to want to put some caps in here. Got to find the short in here. Know there's a short in the other frame. Figure out that other supply, why it's not happy. But just for the one more troubleshooting step, we'll take this supply, put it in the late serial frame, see if it'll fire up. Be real careful unplugging that connector. I just got blasted by the 21 kV. Fortunately, it was a static-ish shock because there wasn't any caps behind it, but I got nailed. That one kind of hurt. Ow. Okay, let's see what happens with this scope. I've kind of settled down and taken the necessary precautions after getting blasted. Fortunately, it was more a static charge than it was a charge with some current behind it, but take it as a reminder to be more careful. All right, here we go. Let's see what happens. Okay, so this supply is ticking now too. So I would bet we have a bad switcher chip, because that was the one thing that I did in this supply was I switched it back to the old switcher chip. So this one may have a bad switcher chip in it, so let me give this some time to discharge. I do not want to get blasted again today. I will put a different switcher chip in. We'll put it back in the other frame. We'll see if it'll fire up. Okay, ready to test this out. Let's see what happens. Good news, bad news? Bad news. We're in tick mode. And every once in a while I see some current, so that's going to be a no there as well. So I'm going to need that load for now 2 power supplies, and it's not the switcher chip. So of the 3 7904s I have here in the lab, all 3 of them are toast. Well, I guess that is what it is. So we'll have some troubleshooting to do, things like that. So we will call this part 1. I got a bit of load. That's the only thing I can do. So these power supplies are going to need some help, and I'm going to have to do that outside of the frame because there's no way to work on them inside the frame, and I don't want to get blasted by 21,000 volts again. With that, that'll conclude this video, and we will get a lot more in-depth in the next video on how these power supplies, on the next video in this series, which may or may not be the next video. Probably not, given the stuff that I have in the queue and the need to build the load. But yeah, we'll go from there. So all in all 3 of my 7904s are busted. But as always, thanks for joining me in the lab. I roll around whether I should post content like this or not, but I was asked to by the patrons, so they want to see the successes and the failures. Not that this is a failure. This is just more troubleshooting is needed. As always, I will see everybody in the comment section, More is always on the way, and I will see everyone in the next video.